Hello, my name is Mr. Lockhart and I'm the line manager for computer science. I'd like to take this opportunity to welcome Mr. Cliffman to the Academy in his role as subject leader for computer science. He'll be joining us after Easter. He's now going to take this opportunity to tell you a bit more about the GCSE computer science course that we will be offering.
My name is Mr. Cliffman and I'm the new head of ICT and computer science. In this video, I'm going to talk to you about taking computer science as an option. Now, the course that we offer is OCR GCSE Computer Science, and within that course, it focuses on two key units of work. The first one focuses on computer systems, and the second one focuses on computational thinking, algorithms, and programming. These are two quite wide areas of the computer science subject, but work actually quite well together to form a very well-rounded qualification. Now, in order to do this course, students must have a keen invested interest in computer programming and computing itself. So they need to actually have an interest in how a computer works, what's inside of a computer, how the software works, how to make computer programs and software. Now, because of the software side of things and the programming side of this course, students will need to be proficient and confident with maths and a wider interest in the technical aspects of computing. Mathematics plays a heavy role within computer science when we look at programming, when we also look at topics such as binary representation, which actually involves using mathematics to solve specific problems. Now, students who may find the mathematical aspect of computer science a challenge may actually want to consider opting for the IT course, as it actually offers a wider skill set on the other side of our qualification. Now, as I mentioned, computer science is split into two units of work. Unit 1, which focuses on computer systems, actually allows us to see what happens within a computer system. So this is to study how the processor works, how memory and storage actually interact and work with the processor, looking at how networks actually function and are created and their different types and topologies, to build skills in the realm of cybersecurity, which in modern times is quite an important skill to have, to investigate how types of software are used within computer systems. This is quite good for when programmers, which is the other part of this unit, actually come to interact with computer systems and need to actually be able to use these different pieces of software, and to also stretch wider comprehension of how computers and computing affect ethical, legal, cultural, and environmental issues. Modern society, because of how widely computing is actually used and computer science is involved within it, students need to be aware of the ethical, legal, cultural, environmental issues that go around with it and how they could impact their potential use of computer systems. Now, Unit 2 focuses on the programming aspects and how actual data is stored within a computer and used. Now, in this case, you're going to study how to actually create algorithms and build a firm foundation of those algorithms and apply them to programming techniques. Throughout that unit, you'll be actually developing computer programs and be able to thoroughly test and make sure that they work properly and also make them resistant to misuse by using techniques such as validation. We'll also be looking at something called Boolean logic and Boolean algebra, which allows for computer systems, and this is where the two units actually link together, allows for computer systems to be able to interpret and send data, and also to look at how computer systems use binary data in its many different ways, whether it be to represent images, sound, text, and even actually the mathematical side of things. And it's Unit 2 where those mathematics skills both come into play. Now, both of these units have a final exam at the end. This course has no coursework. Okay, it is 2 exams sat at the end of the course, so in year 11, both with an equal weighting of 50%. Now, that's not to say that both of these units don't actually include some practical elements, because in order to learn programming, you are going to be practically programming software for different scenarios, and that's where the practical elements come in. And during Unit 1, we'll be looking at physical hardware and network components and seeing how they're all connected together. So although these are both theory-based units, there are practical elements involved to enable students to develop the theory they need. Now, how can this actually allow you to develop in the future? Where can it take you? Okay, very important questions here. Now, computer science itself allows you to actually take it further into A-level and also degree. So you can actually lead the computer science course onwards to do the A-level course and then actually develop your skills maybe as a cybersecurity engineer at university, or a software engineer, or a network analyst. Computer science plays a heavy role within these things and allow for future employment in the computer science industry later on.